Okay, imagine this. You've got consistent, reliable power for your home. Not just when the sun's blazing, but even when it's cloudy, even pouring rain outside.
Sounds almost too good to be true, doesn't it?
It really does. But today we're doing a deep dive into this really fascinating white paper. It's from a group called Black Knight Power.
Ah, yes, the one exploring rain-powered solar technology.
Exactly. And its potential specifically for places like Columbus, Ohio, which might surprise you.
Yeah, places that get a decent amount of rain.
So our mission here really is to unpack these, well, cutting-edge innovations. How could they genuinely transform renewable energy collection, especially in those wetter regions?
Consider this your fast track to understanding the maybe unexpected facts and
hmm
what it could all mean for you.
Let's jump in.
So one of the big challenges, particularly in a place like Columbus, Ohio, is, traditional solar panels. They work great in bright sun,
Right,
but they really struggle with cloud cover, seasonal rain.
right.
Their output just tanks.
They can become almost unproductive sometimes, leaving these gaps in power generation.
Exactly. And that's where this new research, this white paper, gets really interesting.
It highlights a major breakthrough, doesn't it, from engineers over at Suzhou University in China.
Yes, they've developed a hybrid solar cell. And the key thing is, it's not just about sunlight.
It's designed to generate electricity in both sunny and rainy conditions.
That's the idea.
Oh.
It uses something called the triboelectric effect.
Okay, triboelectric, what's that?
Think static electricity, basically, like rubbing a balloon on your hair, that kind of friction.
Ah, okay.
So these engineers added special, clear polymer layers on top of a standard solar cell. When raindrops hit and roll down these layers,
Sure.
precisely, that movement creates a tiny electrical charge, and the panel captures it.
Wow, that's a clever concept. So how are they actually converting that friction, that static, into usable power? And I mean, is it a lot of power right now, or is it more like proving the concept?
Good question. The report mentions the initial tests. We're talking around 33 nanoamperes and 2.14 volts.
Okay, nanoamperes, so tiny.
Very small right now, yes. Maybe enough for a, very low power sensor or something. Definitely not powering your house yet.
Right.
But, and this is the crucial part, it proves the mechanism works. It shows it's feasible. It's a solid proof of concept, even if it's not utility scale today.
Gotcha. So it demonstrates the possibility, opens the door for scaling up later.
Exactly.
And if we bring this back to Columbus, despite its, sometimes gloomy weather, the white paper suggests it actually has pretty decent solar potential overall.
It really does. The paper lays out the numbers. Average daily production per kilowatt installed can range from about 6.23 kilowatt hours in summer down to maybe 2.21 in winter.
Okay, and how does that compare to, say, what a typical home uses?
Well, a typical home might use around 25 to 30 kilowatt hours per day. So a single kilowatt of panels, even in winter, is contributing something meaningful.
And there are ways to maximize that, like tilting the panels.
Yeah, ideally around 35 degrees south-facing. Seasonal adjustments can help a bit too.
And even with the clouds and snow, Columbus is actually making some big moves in solar, isn't it? There are large projects happening.
Huge strides. Just look at the Oak Run solar project out in Madison County. That's an 800 megawatt solar farm.
800 megawatts. That's massive for Ohio.
It's the largest in the state so far. They estimate it could power up to 600,000 homes. So the interest and investment are definitely there.
But the source also points out some roadblocks, right? Why isn't adoption even more widespread?
Yeah, there are hurdles. Part of it is regulatory. In Ohio, for safety reasons, protecting utility workers, you generally can't operate your home solar panels if the main grid goes down.
Ah, okay. So no backup power during an outage from your own panels, typically.
Right. And also, these big projects like Oak Run, they can face public resistance sometimes. This leads to, well, sometimes inconsistent decisions from the Ohio Power Siting Board. It creates uncertainty.
So you've got the potential, the big projects, but also these regulatory things and local opposition slowing things down.
It's a mixed picture.
Does this rain power tech then, I mean, by offering maybe more consistent generation regardless of sunshine, could it potentially help some of those challenges beyond just the weather issue?
It absolutely tackles the weather consistency problem head on. By reducing that dependence on constant sun, it could, theoretically, improve grid stability, maybe even make certain off-grid applications more viable down the line, although the current power output is way too low for that now.
Okay, interesting.
And there's a neat little side benefit the paper mentions. The rain actually helps clean the panels.
Oh, like a free washing service?
Kind of. It reduces dust buildup, which can slightly improve efficiency and might even lower maintenance costs over time.
That makes sense. And people are seeing savings with regular solar already, right?
Definitely. The report cites examples like a homeowner in Northeast Ohio saving around $100 a month on their energy bills. That's significant.
That's a solid incentive. So even though installation is still an investment,
Costs are coming down. Plus, you get long warranties, often up to 35 years on panels and inverters. The typical break-even point is maybe around 10 years.
and you add value to your home, protect yourself from rising electricity costs, there are lots of positives.
So let's sort of wrap up the key takeaways from this deep dive.
Okay.
What we're really seeing is that these hybrid solar panels, the ones that can generate electricity from both sunlight and rain, are a genuinely innovative idea, a potential game changer.
Right. And Columbus, Ohio, with its growing solar market and those big projects like Oak Run, serves as a really relevant backdrop, a good case study for this kind of tech.
Exactly. It highlights both the potential and the real-world context.
Now, we need to be clear, this tech is still very much in development. The current versions, as you said, produce pretty limited power from the rain itself.
Absolutely. It's early days for the rain harvesting part.
But the potential is just huge, isn't it? For maybe revolutionizing renewable energy, giving us a path towards more reliable, clean power, regardless of the weather.
It really pushes the boundaries.
Yeah.
And it leads to a fascinating thought to leave you with.
Go on.
If rain, something we usually see as an obstacle for solar, can actually help power our homes, well, what does that tell us about the sheer, maybe unexpected possibilities for clean energy, even in conditions we didn't think were suitable? It really makes you think about the future, doesn't it? About energy resilience, adaptability,
Yeah.
maybe even in your own life. What else is possible that we haven't even considered yet?